Today's problem 7.26, we have an element in plane stress from fuselage of an airspace subjected to stresses. So you have to determine the stresses acting on the element oriented at an clockwise angle of 40 degree from the horizontal. So given sigma x minus 25.5 ampere, sigma y 6.5 ampere, tau xy minus 12 ampere, and theta is equal to minus 40 degrees since it is in clockwise direction. So sigma x1 is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 plus cos 2 theta plus tau xy sin 2 theta. And putting the values, we get minus 0.461 ampere. Now tau x1 y1 is equal to minus sigma x minus sigma y sin 2 theta by 2 plus tau xy cos 2 theta. Putting the values, we get minus 17.84 megapascal. Sigma y1 is equal to sigma x plus sigma y by 2 minus sigma x minus sigma y cos theta by 2 minus tau xy sin theta. And putting the values, we get sigma y1 is equal to minus 18.539 megapascal. This is the diagram oriented at 40 degree. We get. Now coming to problem 7.215, here also an element is in plane stress from the frame of a racing car oriented at a known angle theta. So I have to determine the normal and shear stresses acting on the element whose axes are parallel to xy axis. That is at theta equals to 0 degree. So given at 30 degree, sigma x minus 15.220 pounds square inch, sigma y minus 410 pounds square inch, tau xy is equal to 2360 pounds square inch, theta is equal to minus 30 degree. So sigma x is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta minus 14,500 psi. Tau x1 y1 is equal to minus sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta is equal to minus 3600 pounds square inch. And sigma y1 is equal to sigma x plus sigma y minus sigma x1 is equal to minus 4900 pounds square inch. And this is the diagram. So for theta is equal to sigma x is equal to sigma x1 is equal to minus 14,500 pounds square inch, sigma y is equal to minus sigma y 4900 pounds square inch, tau xy is equal to minus is equal to tau x1 y1 is equal to minus 600 pounds square inch. Now 7.29, given there is a polyethylene lines settling point subjected to stress. So given sigma x is equal to 350 pounds square inch, sigma y is equal to 112 pounds square inch, tau xy 120 pounds square inch. So we have to determine the normal and shear stresses acting on a seam oriented at an angle of 30 degree to the element. This is the diagram. And we have to find sigma x1, which is minus sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. And then putting the values, theta is equal to 30 degree, and then putting the values, we get 187 pounds square inch. Next, tau x1 is equal to minus sigma x minus sigma y by 2 sin 2 theta plus tau x1 cos 2 theta minus 162 pounds square inch. So sigma y1 is equal to minus sigma x plus sigma y minus sigma x1, which is, and putting the values, we get 275 pounds square inch. And this is the diagram at 30 degree orientation to 7 inch, 187 square inch, and 165 pounds square inch. The normal stresses on the seam equals 187 pounds square inch, and the shear stress on the seam equals 165 pounds square inch against the seam. Now 7.27. So this is the cross section, and this is the side view of B, and this is the element 11,000 pounds square inch, 4,200 pounds square inch, and 3,000 pounds square inch. We have to determine the stresses acting on an element oriented at a counterclockwise angle of 41 degree from horizontal. So theta is equal to 41 degree, sigma x minus 11,000 pounds square inch, sigma y 3,000 pounds square inch, tau xy minus 4,200 pounds square inch. So sigma x1 is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Implying minus 11,000 minus 3,000 by 2 plus minus 11,000 plus 3,000 by 2 cos 2 into 41 degree plus 4,200 into sin 2 into 41 degrees Celsius. So on solving, we get sigma x1 is equal to minus 11,720 pound square inch. Similarly, sigma y1 is equal to sigma theta plus 90 degree is equal to sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 cos 2 theta minus tau xy sin 2 theta. Solving, we get minus 2280 pound square inch. Similarly, tau x1 y1 is equal to minus sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta. And solving, we get 3380 pound square inch. And this is oriented at 41 degrees Celsius, 41 degree. We get this is 3380, 11,720 pound square inch, and 2280 pound square inch. Now 2.5.4, the given there is a steel rod of die 15 mm held between two rigid walls. We have to determine the temperature drop delta T at which average stress is 12 mm in the bolt. Average stress in the 12 mm bolt becomes 45 megapascal. So we have, so the shear stress is tau is equal to P by 2A. So 2P on solving we get and the area is pi dB square by 4. So tau is equal to 2P by pi dB square. And then thermal stress is equal to sigma is equal to E delta T. So sigma is equal to P by S, implying P by is equal to E alpha delta T. So P is equal to E alpha delta T into pi by 4 dr square. So bolt is in double stress, hence tau b is equal to 2r by pi dB square, which is equal to 2 into E into del T into pi by 4 dr square by pi dB square. So tau b is equal to E alpha del T by 2 into dr by dB square. So the temperature drop delta T is equal to 2 tau b by E alpha into dB by dr whole square. When putting the values, we get del T is equal to 24 degrees Celsius. The rod force is P is equal to E delta T into pi by 4 dr square. When putting the values, we get P is equal to 10 kilonewton. Now 7.2, number 1. There is also an element in plane stress subjected to stresses. Sigma x 6500 pound square inch, sigma y 1700 pound square inch, tau xy 2750 pound square inch. So we have to determine the stresses acting on an element oriented at an angle theta is equal to 60 degree from x-axis. So this is the diagram. So we have to find out normal stress in x direction. Sigma x is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Then sigma x is equal to, and putting the values, we get 5281.56. So normal stress is 5281.56 pound square inch. Normal stress in y direction is equal to sigma y is equal to sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 cos 2 theta minus tau xy sin 2 theta. 6500 plus 1700 by 2 minus 6500 minus 1700 by 2 cos 2 into 60 degree minus 2750 sin into 2 into 60 degree, which gives us sigma y is equal to 2918.43 pound square inch. Tau xy in xy plane is equal to tau xy is equal to minus sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta minus 6500 minus 170 by 2 sin 2 into 60 plus 2750 cos 2 into 60 degree, which gives us final tau xy is equal to minus 4905.70 pound square inch. Thank you.